Hello all, welcome to my channel. In this series where we are going through different blogs that I have written earlier and we try to understand the concepts that are present in the blog. So I'm ready with one more blog. This was published way back in 2022, still very relevant because this topic never goes out of fashion because Spark is something which is prevalently used in big data ecosystems nowadays. So this blog, uh, when I wrote this blog, it was majorly to find out how Spark decides which join strategy it will use. Um, when we say join strategy, we know that in SQL we have inner join, outer join, left join, right join. In Spark, there are few more joins like anti join, semi-anti join, semi-left join. So those things, those are actually a relational statement. There is no concrete uh, uh, way. So because Spark internally operates on data frames, it has the concrete implementation of the joins that are there are defined based on certain strategies. For example, join that we are doing inner join might be translated back into broadcast join, might be translated into sort merge join. So we will go through the types of joins and how Spark decides which join to use or which join strategy to use given input. So as this blog starts with, the first thing is it says what are the factors that affect Spark join strategy. So as it documents very well, data size, because broadcast is dependent on the fact that the that broadcasting side table should be good enough or small enough to fit in the memory. Then so that's data size is very important. Then we have join hints. Let's say when we write Spark job, we can give a join hint. Uh, the moment we give a join hint, it Spark understands that okay, the user wants me to use a particular strategy rather than trying to find it of his own. Um, and then Spark generally, when we provide a hint, it will take that hint as a higher priority. In certain cases, in most of the cases, sorry, in certain cases it might ignore the hint, but yes, we will talk about that as well. This blog talks about that. Then also it depends on what is the type of join. So type of join basically says uh, whether it's an equijoin, whether it's a non-equijoin, it's greater than equal to or Cartesian or stuff like that. The reason type of join is very important is, for example, when we have equijoin, so we are checking the equality, which we can check with hash values. But if we are, let's say, having something greater than, less than, or less than uh, that kind of scenario, that kind of checks we can't do based on hash because we will have to find out all the values, right? So the type of join also decides which join strategy will use. For example, if we have an equality statement, it might use a hash join, but not hash join, a sort merge join or a shuffle hash join. But if we have greater than or equal to or something, so there we have to go loop through uh, all the rows to find out whether certain elements is greater or small. So in those cases, the join strategy will be different. Then, as I mentioned, join hints. We give join hints, and then that takes precedence. So there is before I go through this the graph, let's see what are the different types of joins which Spark provides. One is broadcast hash join. So as this figure states, what happens when we have a small data set that can be broadcasted? What it does it will take that smaller data set and it will first send that data set to driver, and that's the constraint that we have, that the table which is smaller one should fit in the driver memory. So it will first send it to the driver memory, driver side, then driver will broadcast it to each of the executors where the bigger table is already there, and then it will perform a hash join. So this is what broadcast hash join is. Again, there's a threshold and stuff like that. Then we have a shuffle hash join. So what it does, because both sides of the join tables are there, so they will shuffle the data, make the same the on based on the columns which on which we are joining. It will try to put all the similar, sorry, same values in the same executor or a worker. And then, so for example, let's say here we have table one, which has, let's say, four different color different hash values, and other one we have in below one, which is having, let's say, one blue and two green. So what it will do, it will try to shuffle the data. So when while shuffling, it will collect all the same values from every worker and put it in one worker from the both the tables and then do a join. So this is shuffle. So it requires data to be moved from one executor to another. So it is a costly operation, and now we can disable this type of join using this prefer sort merge join or flag is there. So if we say that okay, this should not be used, then the sort merge join, which is the next join, will be used. So and in sort merge join, what we do is it is similar to the shuffle hash join. Only thing is that after the shuffling, it also sorts the data. The sorting makes it easier to join because let's say inside one side you have 1 to 10, other side you have, let's say, 12 to sorry, 1 to 100, and let's say we are doing an equality check. So if we have certain things sorted, we know that okay, if we have reached to a point in the left right side which is greater than which is smaller which is greater than the number that we are taking on the right side, so we don't have to look forward because we already know that it is greater than, we can't find an element which is smaller than, so it improves on that. But it is, again, sorting is something which is expensive. So again, this is something that needs to be looked to be taken care of. Then we have a broadcast nested loop join. As I was saying, let's say if you have something which is not an equality join, let's say you have a join which is greater than or smaller than. So those, because we have to anyhow iterate through all the uh, items to see whether we are able to find out the values which are satisfying the condition. So what happens, there is an outer loop which keeps on running for the inner loop. So let's say we have data set 1 and we have data set 2. So for each item in data set 1, it will loop through all the other items in data set 2 and do the check and then return the results. This again, if we have, there are certain conditions, which table is broadcasted. As I mentioned, this is getting broadcasted. So which table gets broadcasted is decided on this, like left side if the it is the right join, right side it is the left outer join or left semi or anti join, and either side can be joined if it is an inner like join, for example. It's not something. So these conditions are there. And then we have one more which is Cartesian, which basically says don't there is no join. It's basically match every row to the every row. Every other row. We can generally Spark SQL cross joins are disabled. This is a fail-safe mechanism, so we can enable it and then do the uh, Cartesian join. This is something similar to a shuffle, replicate, nested lookup join as well, we can say. So these are different types of joins, and based on this, once we have understanding of how each join works, we have this graph which tells which join strategy it will use for which cases. For example, for equijoin, it checks whether the join is equijoin or a non-equijoin. So if it is an equijoin, based on the condition, let's say we are in the equijoin condition, it goes into the yes block. It will see whether this hint is applicable. So user had supplied any hint. If not, if yes, then they use the operator from the hint. So let's say if you have given the broadcast hint, it will take that hint and apply that strategy. If not, it will see whether we can broadcast it. Then it will do a broadcast hash join. If not, sorry, if not, then again it will check whether we have a prefer sort merge join flag set. If we have set that flag, and local hash is sorry, if that we have set the flags, then it will check whether the rows are sortable or not, because it as I mentioned, the sort merge join will have a sort phase, but if the rows are not sortable, there is no point of doing that. So if that not the case, it will again go back here. But if let's say we have disabled that, then it will check whether we can create a local hash. So because in shuffle we shuffle data to the executor which have the same same keys. So if the local hash is possible, it will go to the shuffle hash join. If not, then again it will go to the sort merge join. And in the sort once join, it will what it will do again. It will move, shuffle the data first, and then do a sorting, and then do the join part. Then we have if none of these conditions satisfy, then it will go to either a Cartesian product or it will go to a broadcast nested loop join. Loop. So this is one part. Same goes with the other part where it is a non-equi join. Let's say it is a greater than, then it will check whether there is a hint. If no hint, then it will go to broadcast. We'll see, but we can do a broadcast nested loop. If not, then Cartesian. Otherwise, it will go to broadcast nested loop join. So this is how Spark decides on different join strategies. There are few caveats to broadcast when we have AQE enabled. So one is that if you have, let's say, a left join that you have enabled, trying to do a left join, and you have a hint also is given that okay, you do the broadcast. In left joins, the always Spark always does a broadcast of the table which is on the right side. So in those cases, although you might have given a hint, it might not do a broadcast join because if the right side may be bigger. So there are certain cases where we have to. I'm not sure which side is goes. You will able to check, but yes, in those conditions, there are caveats to understand. But in this blog briefly talks about all those join types and how Spark chooses one join strategy. So yeah, in the next blog, I will try to collect all the conditions. I have written another blog which says what are the conditions in which a broadcast will not happen. So yeah, I will try to collect that and then show you. So this was it. Go ahead and read this blog as well if you want to refresh your memory. So this is uh, all for today. We'll see you next time. Have a nice day.